Hey guys, we're on Unit 4. This is day 1. We're talking about transformations in the coordinate plane. And the warm-up says, determine if a triangle with side lengths of 103 feet, 37 feet, and 96 feet is a right triangle. And so your keywords is right triangle and the fact that these are sides. And remember, anytime they're talking about sides of a right triangle, those three sides have to work in the Pythagorean theorem. A squared plus b squared equals c squared. Okay, keep in mind that the most important number, the largest number, has to go in for C. This is the hypotenuse, right, if it is a right triangle. But if these three numbers are going to have any chance working in the Pythagorean theorem, that largest side has to go in for C. Okay, and then these other two can be A or B, or B and A. All right, those ones don't matter. All right, so here we go. We're going to go ahead and take out A, and we're going to go ahead and put in 37. Don't forget to square it. Plus, take out B and put in 96. Don't forget to square it. Equal to our C, which is 103. Don't forget to square it. Okay, take your calculator, type in 37 squared plus 96 squared, and hit enter. And the answer is 10,585. We're going to see if that's equal to the right-hand side, 103 squared. Put it in your calculator, hit enter, and the answer is 10,609. And these two sides are not equal, and therefore this is not a right triangle. Okay. All right, so going down, we're going to talk about graphing, because that is what we are going to be doing in this unit, a lot of graphing on the coordinate plane, okay, and doing some transformations. All right, the Cartesian coordinate system consists of a coordinate grid separated by the x and y axis. So x-axis, and the x-axis is the horizontal one, okay? And the y-axis. The y-axis is the vertical one. Okay, the intersection of the x-axis and the y-axis happens right in the middle of our graph, and that point is called the origin. Okay, it has coordinates of 0, 0. Okay, the two axes divide the grid into 4 quadrants. It's a 4. It's a bad looking 4. We'll fix that. 4 quadrants. Okay, and they're numbered 1 through 4. And they're numbered in Roman numerals. Okay, kind of important that you use Roman numerals as well. In order to understand the quadrants, okay, if you think about a C going through all 4, where your C starts is quadrant 1, where it goes to next is quadrant 2, where it goes to next is quadrant 3, and where it finally ends up is quadrant 4. Okay, so 1 is in the upper left-hand corner where everything is positive. Quadrant 2 is in the upper right-hand corner. Okay, and then quadrant 3, and then quadrant 4. All right. Every point on the grid can be identified with 2 numbers called coordinates. The first number is the x coordinate. Okay? You don't have to worry about this word, but that is an old school word that they used to use. Okay? We don't really use it too much anymore. The second number is the y coordinate, okay, or the ordinate. And again, they don't use those words too much. So as long as you know the first number in the ordered pair is the x, and the second number is the y, that's good. Okay, for every point, the coordinates are written x comma y, so x is always first. It's also alphabetical order, so easy to remember. When in this form, they're called an ordered pair, and the coordinates of the origin, which we already talked about, is 0, 0. Okay. All right, going down in bold here, it says all graphs you draw must be labeled with the x-axis and y-axis and the scale, if anything other than going by 1s. So if your scale is going by 2s, then you have to make sure that you write that on your graph. Okay. These are postulates regarding points and lines on the coordinate plane, and it says that 2 points are on the same horizontal line if and only if they have the same what. So I always like to go ahead and look at this because that's hard to come up with. But on the same horizontal line, horizontal, like the horizon that the sun comes up over, Okay, notice this is my sun. Okay, this is the horizon. Horizon is horizontal. Okay, it goes left to right. So, for instance, if I graph you a nice horizontal line, and I think about 2 points on there, so we can answer this question. Coordinates of this point might be something like 3, 5, whereas the coordinates of this point might be something like -2, 5. All right, notice what they have the same. They have the same y value because they're up the same amount. Okay, y is your height. So only if and only if they have the same y coordinate. All right, likewise, 2 points are on the same vertical line. So for instance, if I draw you a nice vertical line, okay, we'll keep that point on it, 3, 5. But let's say I pick a point down here. The coordinates of that point might be 3, comma, -2. However, they're still on the same vertical line. They're going to have the same x coordinate. Okay. Each vertical line is perpendicular to each horizontal line. All right. And again, perpendicular lines form right angles. Okay. A transformation which is what we're going to be doing in this unit, is a change in the position, size, or shape of a figure. Okay? The original figure is called the pre-image, pre meaning before you did anything to it, and the resulting figure is called the image. Okay? The transformation maps the pre-image to the image. Okay? Primes are these little apostrophes you're going to see. They're used to label the image. So for instance, if you have triangle ABC, but let's say that you moved triangle ABC by doing like a translation, or maybe you did a reflection. Well, that triangle's still going to be called ABC, but so you know that it's the second one or the one that happened after, they call it triangle A prime, B prime, C prime. So they look like little apostrophes, but in math they call them primes. Okay. And the last one, it says on the coordinate plane, an algebraic rule or mapping defines the transformation by assigning ordered pairs of the coordinate plane to a new location. Okay, and those rules are very helpful to us. They make things quicker, okay, if we know the rule. All right, I'll see you guys on the backside of notes.